Alright, this is a video for 4.7 notes. This is not 4.7 of this problem. This is some homework problems that some people asked me about, so I'm going to just put it in here. It's a good review. You need this for this whole entire module, so I'm going to go ahead and put it in here. But anyway, this is some simplification problems from 4.3 that you need the distributive property for. So I'm going to just show you quickly how to do these. First thing you want to do to simplify, you want to distribute to clear out your parentheses. So I'm going to put both of these two fractions inside of this thing. Okay, now when I do that, I'm going to show the steps, but this is 1/2 times 9y minus, because of the minus sign right here, 1/2 times 2. Alright, remember the way it works is you multiply what's outside by each thing that was inside, and you keep the sign between the two products when you multiply. Okay, same thing here, positive 1/4 times 2y, and then a positive 1/4 times 9. Alright, and then now you can't multiply numbers by letters or the variables, so the only thing I can do is multiply the number times the other number. So I'm going to put 9 over 1, I'm going to put 2 over 1, 2 over 1, and 9 over 1. Okay, these whole numbers that were in the original problem, I'm just putting them over 1 so they look like fractions. Okay, remember, a fraction is a division, right? 9 divided by 1 is 9. 2 divided by 1 is 2. Okay, so these are equivalent. It's just that in fractional form I can see how I'm supposed to multiply them. Alright, now 1 times 9 is 9 up top. 2 times 1 is 2, and then there's a y there. Okay, now with the fractions, in this case, 1/2 times 2 over 1, I can cancel this 2 with this 2, and the only thing left here is 1. You can put 1s here if you want. 1 times 1 is 1, over 1 times 1 is also 1. And then that's just 1. 1 divided by 1 is 1. But here, you got to be careful because the 2's up top, it's the 4's down below. So when we reduce here, we get 1 times 1 is 1 up top, plus 1. 2 times 1 is 2 on the bottom. So that's 1/2 y. Alright, and then here, 1 times 9 is 9, and 4 times 1 is 4. Okay, and then just notice the signs are just coming straight down from where they were in the previous problem, or previous step. Okay, now, like terms, anything that has a y is a like term, so these are like terms. And then these are like terms, the things without the y's. So I'm going to add the two things with y's together. I'm going to regroup them. Okay, this is like the commutative property. I'm allowed to move this -1 here and this 1/2 y here. So I'm going to add those two together. And then I'm moving the -1 over here beside the positive 9/4. Remember, we're allowed to do that. That's the commutative property that says I can just flip-flop these two right here. Alright, now my y's are together, so I can add them. Same denominator. Okay, so that means I just keep that denominator. And then add the numerators. 9 plus 1 is 10 over 2y. Alright, then here, when I'm adding the numbers, I need a common denominator. This is 1. I can write 1 or -1 as -1 over 1, and then to get a denominator of 4, I multiplied here by 4, so that means I need to multiply here by 4. Alright, so that means this piece right here I can write it as -4 over 4 plus 9/4, and now these have the same denominator, and I'm ready to simplify this thing. Right, 10 divided by 2 is 5y, minus 4 plus 9 is positive 5, and then the common denominator is 4. Alright, and there is my simplified expression. Okay, some trouble people were having with this, they were trying to make this into a mixed number and it wasn't accepting it. And just note, improper fractions are fine. The only thing you want to do is just reduce this if it has any numbers in common. Alright, and then one like this, again, just distribute and combine your like terms. Okay, only one set of parentheses here, but a negative times a negative is a positive. 3 times 3 is 9, but there's a decimal point right there, so that's going to be a positive 0.9 y. And then the same thing, a negative times a negative is a positive. 3 times 3 is 9, but again, because of the decimal, it's just going to be 9/10. Alright, and then plus 3.2 y. Alright, and then like terms. The y's are like, this is not like. So when I combine the y's, 0.9 plus 3.2 gives me a 4.1 y. Okay, because those are the y terms. And then I add 0.9 to it. Okay, now you cannot add 4.1 and 0.9 and get 5, because this is not just 4.1, it's 4.1 y. Alright, and then this is not got a y, so they're not like terms, so that's as far as you can take it. Alright, so those were some problems that people had in their homework, and I just wanted to show you that before we did the notes. Alright, this section we're talking about linear word problems. Alright, they call it problem solving, but it's what we used to refer to as word problems. In this section, you do a lot of translation from math, or from English into math expression. Okay, so using x as the unknown number. So everywhere you see the number, you're going to replace it with an x. So twice a number is equal to 4 times the sum of the number and 6. Okay, so that's always going to be where the x is. Now the other thing you got to get used to are these answer words. So I refer to words like sum, difference, product, and quotient. I call those the answer words. And when you see an answer word, you look for and. I want you to think of the word and. Right, and's a very common word in our language. So it's not necessarily the only and that's going to show up in the problem. But usually the first and that follows one of these answer words is what you're going to associate, where you're going to put your operation symbol. So what I mean by that, here's sum, there's the word and. Here's sum, there's the word and. Where that and is, I associate that with the operation symbol. So there's sum, there's and, I put a plus sign there. Okay? And then what goes in front of that plus sign is what's in front of and. Twice a number, 2x. What goes after that is the number that's after the word and. So 4. And then obviously is equal to means that. The sum of, there's again the number, that's x and 6. So there's how this thing would translate to. Now all we have to do here is just write it as an equation. So we're done once we've got it translated. Alright, a few later we'll actually solve them. Alright, using x as the unknown number, translate this. 3 times the number minus 8 is equal to, so 3 times the number would be 3x again, minus 8 is equal to 2 times the number plus 9. Alright, so some of these translate very, very easily, just straightforward. Alright, now when you get to stuff like this, what you got to know is twice the sum, twice the difference when you see those, or times the sum, times the difference. when you see times the sum, I want you to think the distributive property, A times B plus C. And when you see times the difference, same thing. A times B minus C. Alright, so in this problem up here, we've got twice the difference. Okay, that's the same thing as times the difference. It's just we're being specific, multiplying it by 2. But because we're multiplying a difference, remember a difference is the answer to a subtraction problem. So if you're going to multiply the answer to the subtraction problem, that means that you actually did the subtraction before the multiplication. And the only way that could happen is if you have a parentheses, because multiplication normally would trump subtraction. So we have to put that in a parentheses. Twice the difference. Alright, difference is an answer word. So I look for and. So there's where my subtraction is going to be. Okay, the difference of a number, so that's x, and 2. Alright, and then is it equal to, that means our parentheses ends. So is equal to 3 times the sum. So there's another instance where we're going to need a parentheses. Because if we're multiplying the sum, we add it first. So 3 times the sum of, again, there's sum, we look for the word and. So there's where our plus sign is going to be. The number and 4. Alright, now this particular one tells us to find the number. Alright, it was right beside this. I moved it so I could get the translation down. Okay, so this is our equation. We were told to find the number, so we're actually going to solve this. So we need to distribute the 2 through on the left. We get a 2x. 2 times negative 2 is negative 4. Equals, on the right we also need to distribute since we got parentheses. 3 times x. 3 times a positive 4 is a positive 12. Alright, and then solve. Okay, I got x's, constant, constant. So I need to move this x over to this side to get a 1x. Alright, remember our goal is 1x equals, so whatever gets us there quickest. So the 2x's are gone over here. The only thing left on the left is a negative 4. 3x's minus 2x's is 1x, and it's fine if you put the 1x there. But I do want you to understand that 1x means 1 times x, and 1 times anything is just x. Alright, now that I've put my variable on the right, that means I need to put my numbers on the left. So I need to get rid of this 12. Alright, if I do it to the left, I do it to the right. 12s are gone on the right. Instead of writing 1x, I'm just going to write x. Negative 4 minus 12 is negative 16. And there's our answer. Alright, now when you do this, I know our final step when we were doing problems like this last chapter, our last section was check your work. When you check your work, you need to check it here in the wording, not here in what you set up, because if you didn't set it up right, you might have done all your work correctly from the time that you had set it up all the way down. But if you didn't set it up right, it still may not work in the original wording. So always check in the original wording and replace what you get for your answer with where it said a number or the number. So we'd put a negative 16 there, a negative 16 there, and we'd see if it worked. Twice the difference of negative 16 and 2. Well, negative 16 minus 2 is negative 18. Twice that is negative 36. So left side we get a negative 36. Right side, 3 times the sum of negative 16 and 4. Negative 16 plus 4 is negative 12 times 3, negative 36. So it does work in the original wording. Okay, so that's what we mean by check it here in the original statement rather than what you set up, just in case you set it up wrong. Alright, this particular problem in your work is going to be all together in a paragraph. I've got it separated to show you how to translate it. Okay. Now when you're looking at problems like this, sometimes they'll tell you what your variable is going to be. X is the length of the first piece, and so everywhere I see the first piece, that's where the X is going to go. Okay, but other times, like with some problems we'll see towards the end, if they don't tell you specifically what to make X, you have to decide, and the way what we usually do to decide is what we know the least about. Okay, but they tell us to let X be the first piece here, so everywhere I see the first piece, that's going to be my X. Okay, now down here it's just telling me that, so I don't need to worry about it down here. Alright, now we need to make a sentence right here. The second piece, or an equation, the second piece is equals 3 times as long as the first piece, 3 times X. So the second is 3 times X. The third piece is 4 times as long as the first piece, so that means 4 times X. Alright, and then we want to find the lengths of all 3 pieces. Well, this first sentence says it's a 16-inch board that we're cutting into 3 pieces. So that first sentence is telling me that the first, second, and the third pieces add up to 16 inches. Alright, well the first is X. The second is 3X. Alright, no need to put the dot there. And then the third is 4X. So that's what adds up to 16 inches. And if I add these together, X plus 3X is 4X. 4X plus another 4X is 8X. Equals 16 inches. So dividing both sides by 8, I get X is equal to 2 inches. Alright, and what did I just find? X is the length of the first piece. So that's the first piece. But we have to find all 3. You got to make sure that you're answering the question asked. So we have to find all 3 pieces. Well, that's the first, is 2 inches. The second is 3 times that. So the second is going to be 6 inches. And then the third is 4 times that, 4 times this number, so the third equals 8 inches. And if you add those up, 2 plus 6 is 8, plus 8 more is 16, and that's what it has to add up to. Alright, a problem like this, you can use just logic, common sense. If you ever rented a car, or if you have to keep track of mileage for your work or a job you've ever had, you can just use common sense. This you don't have to set up an equation. I'm going to show you how to set up an equation, but you'll see you do the same thing. So they advertise renting a car for this much per day and this much per mile. He rents the car for 3 days. Okay, so he's going to spend this much 3 times. How many miles can he drive? He has a $200 budget, so how many miles could he drive? So the first thing we could do is just figure out how much he's going to spend for those 3 days. So we multiply the cost per day times how many days he rents it, right, and we get $83.85. So $83.85. That's how much he spent on before mileage. So we could take that off of this $200 budget because he's already going to spend that much in just renting it for that 3-day period. So there's $116.15 is what he has left. Now, what are we going to do with that $116.15? Well, every mile that's driven, we're going to subtract off 34 cents. So we're repeatedly subtracting off this 34 cents every time he goes a mile, so that's division. So we're going to take that 116.15 and we're going to divide it by 0.34 cents per mile, and that'll give us how many miles he can go. So that divided by 0.34 is around 341.62, but it wants whole number miles, so just 341. Even though this would round to 342, he can't quite go the 342, so we would just cut it off and say 341. So 341 miles. Alright, now if you did set this up as an equation, what you would set up is the costs, the daily cost plus the mileage cost equals the total budget. So the daily cost, 27.95 times 3, plus the mileage cost, which is 0.34 times x, because we don't know how many miles, is equal to the budget. Alright, so there's the equation you would solve. And how would I go about solving this equation? Well, first I would multiply these together, which is what we did first. And then I would start to get this x isolated. I'd subtract this over, which is what we did second. Alright, and then after I did that, I would divide by the number in front of x, which is what we did third. So even if you did set it up with an equation, you would still do the exact same thing that we did, just using logic and our understanding of how this problem would work out. Alright, this problem, it takes a little bit of geometry, understanding geometry to set this up. So first of all, they tell you this is an isosceles triangle, which means that two sides are the same length and those opposite angles are also the same measure. So this pair of angles are equal, these pair of sides are equal, and then this side, the longer side here, that corresponds to this longest angle or largest angle, are possibly different than these other two. Okay, so it tells us the measure of the third angle. They're talking about this one, the biggest angle, because the other two, 1 and 2, are already known, are the ones that are the same. So the third angle, the one that's different, is 45 degrees more than 3 times the measure of either of the other two. Now again, what you have to get yourself trained to do is to see how this is going to translate. The third angle of the triangle, so I'm just going to say third, is, so there's where we're going to get our equation from. The third is 45 degrees more than, that means we're going to add, so 45 degrees more than 3 times the measure of the other two angles. Okay. Now we're not told what to use for x here, but what we know the least about are these two angles, these unknown values down here, and that's what we let x be. Okay. We're told a little bit about this third one, but we're not really told much about these two. So that means those are my x's. So the third equals 45 plus 3x. Okay. Find the measure of each angle. Okay, now what you have to understand, they tell you this in the problem in parentheses, but they tell you that the first the second and the third angles add up to 180 degrees. Alright, well the first and second are both x. This is our first, our second. These are both x. So that's an x plus an x plus the third is what we just found out right here. Is 45 plus 3x. So these are the things that add up to 180. Alright, and just counting, I got 1, 2, and then 3 more 5x's. So 5x plus 45 equals 180, and then subtract 45 from both sides. Alright, so 5x is equal to 180 minus 45 is 135, and then divide that by 5. So 5 goes into 13 2 times, with a remainder of 3, 5 goes into 35 7 times. So the two smaller angles, this one and this one, are 27 degrees each. Alright, and then the third one we can get by plugging 27 into here, or we can get it from subtracting from 180. Okay, so what I mean by that is I can say 180 minus 27 minus another 27 and get that, or I can take 27 and plug it in for the x, so 45 plus 3 times 27. Either way, I get the third angle to be 126. So 126 degrees is that third one. The other two are 27. If you add them all up, you get 180. So that means we did it right. Okay, this one, same idea, except it's a parallelogram now. So we have the angles A, B, C, D add up to 360 now instead of add up to 180. Okay, A and D had the same measure, so they're saying the measure of angle A is x. So that means the measure of angle D is also x. Alright, and then C and B also have the same measure. So these two angles are also equal in measure. Alright, and then they tell us the measure of angle C is 4 times the measure of angle A. So this is 4 times x. And C and B have the same measure, so this is 4x. Alright, find the measure of each angle. The sum of the measures is 360, so if I add up all these four expressions, x plus 4x plus 4x plus x, I should get 360. So adding them all up, I get a x, 4 and 4 is 9x, plus 1 more is 10x. And then divide both sides by 10. Remember, when we divide by 10, if a number ends in 0, that last 0 goes away. So we end up with 36 degrees for x. Alright, so that means the measure of angle A and angle D are both 36 degrees because those both had x as their measure. And then if we multiply that by 4, we get that the measure of angles B and C is both 144. Alright, again, add all those up and you'll get 360. Alright, the next couple of questions are consecutive integer questions. Consecutive integer means like 1, 2, 3, negative 4, negative 3, negative 2, 12, 13, 14, negative 15, negative 14, negative 13. Okay, they're just in order, back to back to back. Alright, and integers can be positive or negative. Okay, now what they're showing you here in this table is that if x is the first integer, the one after that is x plus 1. The one after that is x plus 2. So just think about it for a second. Let's say our first integer was 3. What's the number after that? 4, which is 3 plus 1. And then the number after that, 3 plus 2. So we get 3, 4, 5. So this does work. Okay, I just want you to understand that this does work. This consecutive integer stuff. It is giving you what you're supposed to be getting. You're getting whole numbers in order, positive or negative. Alright, so the sum of 3 consecutive integers simplified. Alright, they want us to keep it with x. So the sum means we're going to add them together. So x plus x plus 1 plus x plus 2. If I add these three things together, I have 1, 2, 3 x's, and then I have a 1 and a 2 that are like, and I'll add those and get a 3. So that's what they're wanting there. 3x plus 3. Okay, and again, pick any number, 1 plus 2 plus 3. If I add those together, I get 6. We'll put in a 1. That's what x is. It's the first number. Put in a 1 there. 3 times 1 is 3, plus 3 is 6. All right, pick different numbers. Pick 10, 11, 12. 10 plus 11 plus 12. Okay, 10 is the first integer. That's where the x is. So 3 times 10 is 30, plus 3 is 33. 10 and 11 is 21, plus 12 is 33. So this will give you the sum of 3 consecutive integers if you put in the first one, the smallest one. Alright, now, the reason why I'm showing you this other one is because you have to be careful what you're looking at. You're not always doing the same thing. Some of the first and second. It doesn't want all 3. It just wants the first and second. So you have to be careful. This is giving you 3, but it only wants this one and this one. Alright, if I add these two together, I get x, and x is 2x plus 1. Okay? So just make sure you're paying attention to what they're asking you to find in this last box. Alright, the next type is consecutive odd integers, and this works the same for consecutive evens. But if you think about consecutive odd integers, they're different than just consecutive integers in general because the gap between them is not 1 anymore. The gap between them is now 2. So to go from 1 to the next, I add 2. Alright, so the next integer after x is no longer x plus 1 like it was here. It's now x plus 2. Alright, because to go from 1 to 3, or to go from 9 to 11, or to go from 173 to 175, you add 2. And then the one after that, again in terms of x, is x plus 4. Right, from here to here, to go from 1 to 5, I'm adding 4 instead of adding just 2. Okay, so x, x plus 2, x plus 4. Again, pick any number, any odd number. So let's say we started at 19. Add 2, you get 21. Add 4, you get 23. And these are consecutive odd integers. Okay, so just make sure you understand what we're doing here on the top line. Alright, and then they want the sum of the second and the third. So only this one and this one. So that means we're going to add x plus 2 and x plus 4. So that's 2x plus 6. And that's what we would put right there in that blank. Alright, and then some train problems. Distance, rate, times problems. The sum of the speeds of two trains is this. If the speed of the first train is that much faster than the second train, find the speeds of each train. This is what I was talking about before. If they don't tell you what to let x be, you decide what you know least about. Okay? The speed of two trains. Alright, we don't know, anything about either one really other than their sum. But here it says if the speed of the first train is blankety blank miles per hour faster than the second train. So it's telling us some information about the first train. It's going faster than the second. But we don't know anything in detail about the second. So we're going to let x equal the second train speed. Alright, so if that's the second train speed, then everywhere I see the second train, I get to put an x there. Okay, so the first is, so that means the first train equals 8.4 miles per hour faster. So if this one's going 10, this one's going 18.4. If this one's going 40, this one's going 48.4. So faster than means we're going to add to this speed. Alright, and then the sum of these two numbers is this. So if I add this and this, I get this number. So there's my equation. 8.4 plus x, that's the first train, plus the second train, plus another x, equals 725.6. Okay, so first train plus second train. Make sure that you see that this is the first train. And that this is the second train. Alright, first train plus second train equals this. So that's where that's coming from. Alright, like terms, so I got 2x's, 8.4 plus 2x equals 725.6. Alright, subtract 8.4 from both sides. Alright, that's 2x equals 17.2, and then divide both sides by 2. And I get, x equals 717.2 divided by 2, 358.6 miles per hour. And what is that? That is, according to what we wrote, the second train. The first train is 8.4 miles per hour faster. So I take that number, I add 8.4, and I get the second train, or sorry, the first train. Alright, so that adds 10, carry your 1, 16, 17, or 17, carry your 1, 6, 367 miles per hour is the first train. Alright, there's the first train, there's the second train. Alright, last couple of these. Two angles are supplementary if their sum is 180, so that means they add to 180 these two angle measures. And then again, there's something to translate. The larger angle measures, there's our equals, 4 degrees more than 10 times the measure of the smaller angle. X represents the measure of the smaller angle, so right there is where my x is going to be. So the larger angle is, or measures, 4 degrees more than 10 times the measure of the smaller. So 10x, there's the larger. And these two things are supplementary. So this plus the smaller angle adds up to 180. So 4 plus 10x, that's the larger, plus x, that's the smaller, adds to 180. Alright, add that, that's 11x plus 4 equals 180. Subtract away the 4 from both sides to get the 11x by itself. Alright, 11x equals 176. And then divide both sides by 11. Alright, x, which is the smaller angle, 11 goes into 17 one time, the remainder is 6. 11 goes into 66 6 times. So the smaller is 16 degrees. And that means the supplementary angle, or the larger angle, is 180 minus that, which is 164. Alright, if you have any homework questions, just send them my way and I'll see if I can help you in this section.